Hello and welcome. In this video, we are going to scrape a website with the Robomotion Web Recorder. The idea is simple. You do the work once in a normal browser, and the recorder writes down the flow that does it again. This is the page we are going to scrape, the deals that are ending soon on AppSumo. Every product is a card, a name, a category, a description, a rating, and a price. A row of a table drawn as a card. A screen full of them today, and the same shape repeated all the way down. That repetition is the thing worth noticing. It is what lets us describe one product and get all of them. What we want out of it is a table, one row per product, and a file we can open in a spreadsheet. We start with almost nothing, a project and an Inject node renamed to Start. Everything else on this canvas is going to be written by the recorder. Back in the designer, the record button sits beside Run and Stop. It asks which machine to record on. That is a machine with the Robomotion agent connected and the Robomotion extension in its Chrome. Web for browser work, start recording. The recorder opens on that machine, beside the browser we are going to work in. It is not recording yet. Its own record button starts the capture, so you can get the browser to where the work begins first. And the first two things it writes down are the browser being open and the page being open. Now the values. Right-click the first product name, and the menu offers everything a browser node can do with it. Get value and its text, that is one product read. Do the same on the second product, and something better happens. The recorder notices that two similar things have been picked and offers to read every item on the page the same way. Extract data, one answer and the two picks become a whole list. The two get values are gone, replaced by a single scrape list step. Open it and you can see what it would return right now. 3 columns were found, the text of each card, its link and its image, and underneath, a preview of every row it would return. The first column is the whole card, not the name. The target button fixes that, press it, and the picker comes back to point the column at what you meant. Click the product name, and the column follows. Every row now reads just the name. The field names are the column names, and the first one is still called text. Double-click it and change it to product. Link and image already say what they hold. Back to the list. One thing to tidy. Pointing at that column was a click on the page, and the recorder wrote it down. The list is editable. Throw it away here, rather than in the flow. And that is the recording. Done sends it to the designer. And there it is on the canvas, not a script, but a subflow of ordinary nodes. Wire it to start and save. A robot runs what is saved, not what is on your screen. A recording is a subflow, and a subflow opens like any other double-click. Open browser and open link, which is the recorder writing down how it started. And scrape list, which is the whole table in one node, the two picks generalized. And they are ordinary nodes, which is the point. Open one and everything it captured is a property you can edit. Here are the columns, a name and a selector each, exactly what the recorder showed us, and every one of them editable from here. Back out to the flow. The scrape list node hands its table to the rest of the flow in the message as msg.table. So anything that reads a table can take it from here. Pull a wire off the subflow and ask for write CSV. Its table property already reads msg.table because that is where the scrape put it. Nothing to change. It needs somewhere to write, on the machine the robot runs on. And headers on, so the column names we chose become the first row of the file. One more node, and it is the difference between a run that ends and a run that just sits there. Pull one more wire, this time off write CSV, and ask for stop. It tells the robot the job is finished, the run ends, and the browser it opened closes with it. Save. Now run it on a robot. The robot opens its own browser. This one is not ours to drive, it is the flow driving it. The page opens, and the list is read in one go, one node doing what our two picks described. Then write CSV puts the table on disk, stop ends the run, and the browser closes itself. And there is the file the robot wrote, opened in a spreadsheet. Product, link, and image, the names we gave the columns as the header row. And under it, every deal that was on that page, read in one pass. One last thing, because you will not always want to record a whole session. Any node that needs a selector can go and find one for you. Here is a click element on a different page. Hover it and an inspect button appears underneath. The same machine and the same app as the recorder, but this time it opens on one element instead of a whole session, and it waits for you to point at something. Press inspect and the page belongs to the picker. The cursor becomes a crosshair. Whatever is under the pointer is outlined and named. This one is an anchor. Right-click it and the menu offers exactly what the node that sent us here can do. Click this element, take it, and the pick is done. The whole path back to the document is here, one row per level, with the attributes each one could be matched on. The ticked one is the text, and underneath is the selector it built, with a count of how many elements it matches. 1. Test is not a preview. It performs the action, so a click element under test really clicks, and the page really moves. Done hands the selector back to the node that asked for it. And there it is, in the selector property, the box you would otherwise have typed an XPath into. Pointed at instead of written down. So, record the job once, and what comes back is a flow you can read, edit, and schedule. Thank you for watching.